Hi, in this lecture, we'll be talking about a very important machine learning concept, what you call feature scaling. So here I am showing a snapshot of a data frame, and in the table we have two columns, the height and weight of some people, and you can quickly figure out that as the height unit is in meter, so the values are within the range of, let's say, 1.5 to 1.8 max. And if you look at their corresponding weight in kilogram, you will find that the ranges are between 70 to 82. So how this affects vector space axis weights? So that is the general idea to learn. So let's try to plug those values. And in the x-axis, we are plotting the height, and then the corresponding weight are on the y-axis. So let's plug the first person's height, and it turned out to be in this location. But how do we plot the weight? Okay, because in the vector space, you assume that the units are the same. Okay. In real world, it's not like that, right? Because we have height and weight, they are in two different units, but in the vector space, we have the values in the grids, right? So if you want to plug the weight, it turned out to be that it is going out of the screen, okay, or the slide. So how do you actually compress those to fit into this vector space? Do you have some ideas? So let's say someone gave us the idea that, oh, I want to divide by 25. So as soon as you divide by 25, your values become in a lower scale, and you are able to plug them, right? But you can figure out that the weights are kind of almost double than the height, okay? So still you fixed the scaling a little bit, but it was not entirely fixed. Imagine that we have idea about the k-nearest neighborhood model, and if we want to do a similarity estimate, then definitely it is going to put more weight on the weight compared to height. So these are some of the models that are purely dependent on you to scale your data properly, okay? So one smarter idea is that, like I want to divide by the maximum value of the each column, okay? And it turned out to be that yes, we were able to compress all the data in the first quadrant. So what is a better way? So that's what we call min max scalar. So if you do this equation, so for each value, you first subtract the minimum of each column from the value in your consideration and divide by the max mean value difference. So if you do that, then your value will be properly spread over the square area, okay? So this is the famous min max scalar. And then we have standard scalar. So if your data values, for example, height or column, they follow Gaussian distribution, then your new value will be, you subtract the mean of that column and divide by the corresponding standard deviation of the column. So if you do that, your value will be scaled. So if you pay attention here, we have these values following a Gaussian distribution. If we do this standard scaling, your value will be centered across 0, okay? So that's why in one of our notebooks, we were finding that we have negative values, okay? Because the data was scaled using standard scalar. So now I will go to the notebook presentation, and again I have added the notebook as part of the description. So let's take a little bit time. So here we'll be using the same notebook that we have used for our feature encoding presentation, and we were preparing your data to learn a medical insurance cost prediction. So we load the data, and we figured out that some of the columns, they have numeric values, and some others, they have categorical values. So we used some feature encoding techniques. For example, the one-hot encoder and the label encoder. So this part we already covered. So we did the feature encoding. Now, after we did the feature encoding, we looked at the values of the corresponding columns, and it turned out to be that the age minimum value is 18 and the max value is 64, and BMI, the mean value is 15.96, max value is 15.3. Then children max value is 0 and max is 5, and the rest are 0, 1 values or binary values. So you can clearly see that if I plug this data frame to train my linear regression model or do a KNN model, it will definitely going to give big weights to BMI and age. Okay, so these variables are going to over influence your machine learning tasks. Okay, this part is only applying the min max scalar. So as soon as you have applied min max scalar, you quickly see that the values are all within the range of 0 and 1. But let's activate the standard scalar to see how the values are actually changing. So let's run the standard scalar, and we can see that some of the values are negative. That means that the data actually spread over the 0 axis as we have used standard scalar. So again, I have provided the link of these notebooks in the description box. At any point, if you have any questions, feel free to ask me. Thank you.